The numbers do not match the silence. By every reasonable calculation, the observable universe should be saturated with intelligent civilizations. There are an estimated 200 billion trillion stars within range of our most sensitive telescopes. A significant fraction of those stars host planets in habitable zones. Even if only a vanishingly small percentage of those planets developed life, and only a fraction of that fraction produced technological societies, the galaxy alone should contain millions of advanced civilizations broadcasting their existence across the cosmos. And yet, for over 70 years of dedicated searching, the sky has remained empty. No confirmed signals, no radio transmissions, no probes, no visible megastructures, nothing. This is the Fermi Paradox, and it has haunted physicists, astronomers, and philosophers for generations. But in recent years, something has shifted. The United States government has begun releasing files it spent decades denying existed. Pilots have testified under oath, radar data has been declassified, congressional hearings have featured intelligence officials describing recovered materials of unknown origin. The conversation has moved from fringe speculation to formal record. The question now facing the scientific community is uncomfortable, but unavoidable. If unidentified aerial phenomena are real, and if some portion of them defy known physics, then what does this mean for our understanding of cosmic isolation? Could the silence Fermi described be an illusion? Could the answer have been here in our own atmosphere the entire time? Or are we witnessing something stranger still, something that reframes the paradox rather than resolves it? This investigation begins where the documents end and where the questions truly begin. To understand why declassified files matter, one must first understand the silence they may be filling. The sky above us is not empty in the way most people imagine. It is dense with starlight, packed with planetary systems, and ancient beyond comprehension. The Milky Way alone contains somewhere between 100 billion and 400 billion stars, depending on how astronomers count the faintest red dwarfs at the lower mass limit. Beyond our galaxy, the observable universe is estimated to contain at least 2 trillion galaxies, each with its own population of stars and worlds. The total number of stars accessible to our instruments is so large that human language struggles to describe it meaningfully. It is a number larger than every grain of sand on every beach of every coastline on Earth, multiplied many times over. Within this vast inventory, the conditions for life appear to be remarkably common. The Kepler Space Telescope, launched in 2009, revolutionized our understanding of planetary frequency. Before Kepler, astronomers debated whether planets were rare oddities or common companions to stars. After Kepler, the answer became clear. Planets are not the exception. They are the rule. Almost every star surveyed by the telescope showed signs of orbiting companions, and a significant percentage of those companions occupied the so-called habitable zone, the narrow band of distance from a host star where liquid water could plausibly exist on a rocky surface. The implications were staggering. Statistical analysis of Kepler data suggested that the Milky Way alone could contain as many as 40 billion Earth-sized planets in habitable zones around Sun-like stars. When the more numerous and longer-lived red dwarf stars were included, that number expanded even further. Some estimates push the figure into the hundreds of billions of potentially habitable worlds within our single galaxy. And these were only the worlds we could potentially detect. The true number, accounting for observational limits, was almost certainly higher. Life itself, as far as we understand it, appears to emerge with surprising eagerness given the right conditions. On Earth, the first microbial life forms appeared within a few 100 million years of the planet, cooling enough to support liquid water. This is geologically rapid. It suggests that the chemistry of life is not a rare accident, but a probable outcome wherever the right ingredients combine under the right conditions. The building blocks of biology, amino acids, simple sugars, and nucleobases have been detected in meteorites, in interstellar gas clouds, and in the icy moons of our own solar system. The raw materials for life are scattered throughout the cosmos like seeds waiting for fertile ground. Given all of this, the mathematics of cosmic life becomes almost overwhelming. If even 1 in a million habitable planets develops microbial life, and 1 in a million of those develops complex multicellular organisms, and 1 in a million of those produces a technological civilization, the galaxy should still contain thousands of such civilizations. Expand the calculation to the entire observable universe, and the number climbs into the trillions. By any reasonable estimate, intelligence should be a common feature of the cosmos, not a rare anomaly. And this is where the silence becomes deafening. For over half a century, humanity has been actively listening. The search for extraterrestrial intelligence, known as SETI, began in 1960 when astronomer Frank Drake pointed a radio telescope at 2 nearby sun-like stars and listened for artificial signals. Since then, the search has expanded enormously. Modern arrays scan millions of stars across thousands of radio frequencies. Optical SETI looks for laser pulses. Astronomers have searched for waste heat from hypothetical megastructures, for atmospheric pollutants that might indicate industrial activity, and for unusual patterns in the dimming of distant stars. The technology has improved by orders of magnitude. The sensitivity is now so high that we could detect a transmitter much weaker than our own broadcast capabilities from many light years away. And yet, the result has been consistent. Nothing. No confirmed artificial signals, no unambiguous techno-signatures, no probes drifting through our solar system carrying messages of greeting. The silence is not partial. It is complete. The cosmos appears, by every measurable standard, to be empty of speaking neighbors. This is the contradiction that drove physicists to despair and philosophers to wonder. The universe should be loud. It is quiet. The mathematics demand presence. The observations record absence. Something in our model of reality must be wrong. Either life is far rarer than the chemistry suggests, or intelligence is far rarer than the biology suggests, or civilizations destroy themselves before becoming detectable, or there is something fundamental about the nature of cosmic existence that we have failed to grasp. Each explanation carries its own implications. None of them are comfortable. The strangeness of this silence becomes more pronounced when one considers the timescales involved. The galaxy is roughly 13 billion years old. Earth, by comparison, is only 4.5 billion years old. The first stars capable of producing planets with the heavy elements necessary for life formed billions of years before our sun ignited. This means that any civilization that arose in the galaxy before us could have a head start of millions or even billions of years. A civilization just 1 million years older than ours, a blink of an eye on cosmic timescales, would possess technology so advanced that our most sophisticated science would seem primitive by comparison. Such a civilization, if it existed, would have had ample time to explore and colonize the entire galaxy. Even without faster-than-light travel, conservative estimates suggest that a determined civilization, using nothing more exotic than self-replicating probes, could span the Milky Way in a few million years. Some calculations put the figure even lower. The galaxy is, in cosmic terms, small. Crossing it should be feasible for any sufficiently patient species with sufficiently advanced technology. And yet, we see no evidence of such crossings. No probes in our solar system, no engineered structures around nearby stars, no artificial alterations of the spectra of distant galaxies. This is the heart of what physicist Enrico Fermi famously asked during a casual conversation at Los Alamos in the summer of 1950. If the universe is so vast and the conditions for life so common and the timescales so long, then where is everybody? The question was simple, almost flippant, but its implications were profound. It became the foundation of an entire field of speculative inquiry, a question that has resisted resolution for 3/4 of a century. But here is where the modern era introduces a new variable. For decades, the silence was assumed to be total. The skies were considered empty, the cosmos uninhabited, the question unanswered. Then, beginning in 2017 and accelerating through the years that followed, a series of declassified documents and official statements began to reshape the conversation. The United States Department of Defense acknowledged the existence of programs dedicated to studying unidentified aerial phenomena. Pilots came forward with corroborated accounts of objects performing maneuvers that violated known aerodynamic principles. Radar tracks and infrared footage entered the public record. Congressional hearings were convened. Intelligence officials testified under oath about recovered materials and ongoing programs. The question this raises is not whether the Fermi Paradox is correct as a mathematical proposition. The math remains compelling. The question is whether the silence has been as complete as we assumed. If even a fraction of the declassified phenomena represent genuine evidence of non-human technology operating within Earth's atmosphere, then the paradox does not dissolve. It transforms. The galaxy may not be empty. It may simply be quiet in the ways we have been trained to listen. The answer may have been hiding not in distant star systems, but in the airspace above our own heads, recorded on military sensors and dismissed for political reasons. To understand whether this is plausible, one must first return to the moment the question was born, to a New Mexico desert in the middle of the 20th century, where a Nobel laureate asked a question that nobody has yet been able to answer. The summer of 1950 was hot and unusually still in Los Alamos, New Mexico. The town existed almost in secret, nestled in the Jemez Mountains, surrounded by canyons and pine forests. It had been built during the Second World War to house the scientists working on the Manhattan Project. And even 5 years after the war ended, it remained a closed community of physicists, engineers, and mathematicians working on the next generation of nuclear weapons. The minds that gathered there were among the sharpest in human history. They had split the atom, calculated chain reactions, and now they were turning their attention to thermonuclear devices that would dwarf the bombs dropped on Japan. It was during one of the routine lunches at the Fuller Lodge dining hall that the question was asked. The exact date is not recorded with certainty, but most accounts place it in the early summer. 4 men sat at a table together. Enrico Fermi, the Italian-born Nobel laureate whose work had been central to creating the first nuclear reactor, was joined by Edward Teller, Emil Konopinski, and Herbert York. They were among the most brilliant physicists alive. The conversation began casually, as such conversations often do, drifting from topic to topic. The previous weeks had seen a flurry of newspaper stories about flying saucers. Public interest in unidentified aerial phenomena had been building since the famous Kenneth Arnold sighting in 1947, when a private pilot reported seeing 9 crescent-shaped objects flying in formation near Mount Rainier. Arnold described their motion as resembling a saucer skipping across water, and the press coined the term flying saucer. By the summer of 1950, the country was saturated with such reports. A New Yorker cartoon had recently joked about aliens stealing public trash cans, and the men at the table had apparently been discussing it lightly. As the conversation moved on to other matters, Fermi grew quiet. He was known among his colleagues for this habit. He would fall silent during a discussion, his mind working through calculations and implications, and then suddenly emerge with a question or statement that reframed the entire conversation. According to the recollections of those present, this is exactly what happened that day. After a long pause, in the middle of an entirely unrelated discussion, Fermi looked up and asked a question that is echoed through scientific history. The exact wording varies depending on which witness one consults, but the essence was the same. Where is everybody? The men at the table understood immediately what he meant. Fermi had been performing one of his famous back-of-the-envelope calculations, the kind of rapid estimation that he was legendary for. He had apparently been thinking about the size of the galaxy, the age of stars, the probability of life, and the timescales required for interstellar travel. The conclusion, arrived at silently during the lunch, was that the galaxy should be teeming with civilizations, and yet no contact had been made. No probes had arrived, no signals had been intercepted. The universe was vast, the math was clear, and the silence was absolute. What made the question so powerful was that it came from Fermi specifically. He was not a science fiction writer or a popular speculator. He was one of the most rigorous experimental physicists of his era. His calculations were trusted because they were almost never wrong. When Fermi performed an estimation, the result was generally accurate to within an order of magnitude. He was the man who had estimated the yield of the Trinity nuclear test by dropping pieces of paper as the shockwave passed and measuring how far they were displaced. His mind operated on physical reality with unusual precision. If Fermi thought the math suggested the galaxy should be populated, then the math suggested the galaxy should be populated. The silence was therefore a genuine puzzle, not a mere absence of imagination. In the years that followed, Fermi's question was not formalized immediately. He himself never wrote a paper about it. He died in 1954, only 4 years after that lunch, of stomach cancer at the age of 53. The question lingered in the memories of his colleagues and gradually entered the broader scientific conversation. It was not until 1975, more than 2 decades later, that the astronomer Michael Hart published a formal academic treatment of the problem. Hart's paper, titled An Explanation for the Absence of Extraterrestrials on Earth, laid out the logic with mathematical rigor and explored possible resolutions. He argued that the absence of any evidence for extraterrestrial visitation suggested that humanity might genuinely be alone in the galaxy. Hart's paper was followed by extensive academic debate. Other scientists, notably physicist Frank Tipler, pushed the argument even further. Tipler argued in 1980 that the absence of self-replicating probes in our solar system was strong evidence against the existence of other technological civilizations. His reasoning was straightforward. Any sufficiently advanced civilization would, given enough time, develop the capacity to build self-replicating machines capable of crossing interstellar distances. Such machines would multiply exponentially, filling the galaxy in a relatively short cosmic time frame. Their absence in our own backyard suggested that no such civilization had ever existed, at least not within the reach of our solar system. The debate intensified throughout the 1980s and 1990s. Astronomer Carl Sagan took the opposing view, arguing that the absence of evidence was not evidence of absence. He pointed out that humanity had only been searching the skies with radio telescopes for a few decades, that our search had covered only a tiny fraction of the relevant frequencies and stars, and that we had no real basis for concluding that the silence was complete. Sagan suggested that civilizations might be transmitting on frequencies we had not surveyed, using methods we had not anticipated, or simply existing in forms we had not imagined. The disagreement between Hart and Tipler on one side and Sagan on the other set the terms of the debate that continues today. One camp argues that the silence is genuine and tells us something important about the rarity of intelligence. The other argues that the silence is illusory and tells us only that we have not yet looked properly. Both positions have evolved with time, and the discovery of thousands of exoplanets has only deepened the puzzle. The galaxy is more habitable than we knew. The chemistry of life is more universal than we knew. And yet the silence persists. What Fermi himself would have thought about the modern data is impossible to say. He died before the discovery of a single exoplanet. He never saw the radio telescope arrays that now scan the skies. He did not live to read the declassified reports of unidentified aerial phenomena that began emerging in the 21st century. But the question he posed has proven remarkably durable. It has resisted every attempt at resolution. It has spawned entire fields of inquiry. It has driven the development of new instruments, new theories, and new philosophical frameworks. And it remains, even today, the central unsolved problem at the intersection of astronomy, biology, and the search for cosmic company. The power of Fermi's question lies in its simplicity. It does not require advanced mathematics to understand. It does not require specialized training to appreciate. Anyone who looks up at the night sky and considers the number of stars, the age of the universe, and the absence of visitors can feel the weight of the puzzle. The question is not really about aliens, in the popular sense of the word. It is about probability, time, and the strange asymmetry between what should be and what is. It asks us to confront the possibility that something fundamental about our understanding of life, intelligence, or the universe itself is wrong. In the decades since Fermi posed his question, the silence has not been broken in any officially confirmed way. SETI has produced no verified signals, no probes have been intercepted, no clear technosignatures have been detected. By every conventional measure, the universe remains as quiet as it was in 1950. But here is the complication that has emerged in recent years. The conventional measures may not be the only ones that matter. While astronomers have been listening for signals from distant stars, something else has been happening closer to home. Military pilots have been encountering objects in our own atmosphere that they cannot explain. Radar systems have been tracking craft that move in ways no known aircraft can move. And the documents describing these encounters, once buried under layers of classification, are beginning to surface. To understand what these documents might mean, we must first understand the mathematics that makes the silence so puzzling, the equation that Frank Drake wrote on a chalkboard in West Virginia in 1961, an attempt to put numbers on the question Fermi had asked a decade earlier. Frank Drake was 31 years old when he stood before a small gathering of scientists at the Green Bank Observatory in West Virginia in November of 1961. The meeting had been convened to discuss the prospects of detecting signals from extraterrestrial civilizations. Drake had recently completed Project Ozma, the first systematic radio search for such signals, in which he had pointed the 85-foot telescope at two nearby sun-like stars and listened for artificial transmissions. The search had produced nothing definitive, but it had established the methodology that would shape decades of subsequent work. In preparing for the Green Bank meeting, Drake faced a practical problem. He needed an agenda that would structure the discussion around the key uncertainties involved in estimating the number of detectable civilizations in the galaxy. He sat down and wrote out a series of factors that would determine that number, multiplied together in sequence. The result was a simple equation, almost embarrassingly simple in its structure, but profound in its implications. It became known as the Drake equation, and it has remained the central organizing framework for thinking about the Fermi Paradox for more than 60 years. The equation begins with the rate of star formation in the galaxy. This is multiplied by the fraction of stars that have planets. That product is multiplied by the average number of planets per star system that could potentially support life. That is multiplied by the fraction of those planets where life actually develops. Then, the fraction of life-bearing planets where intelligence evolves. Then, the fraction of intelligent civilizations that develop technology capable of broadcasting their existence. And finally, the length of time such civilizations remain detectable before they either go silent or destroy themselves. The elegance of the equation lies in its modularity. Each factor can be estimated independently. As scientific knowledge advances, individual terms can be refined without disturbing the overall structure. When Drake first wrote the equation in 1961, most of the factors were essentially unknown. The rate of star formation was uncertain. Nobody had yet discovered a planet outside our solar system. The biology of life was poorly understood. The lifetimes of technological civilizations were complete guesses, informed more by the recent invention of nuclear weapons than by any empirical evidence. Over the decades that followed, several of these terms have become much better constrained. The rate of star formation in the Milky Way is now well established at roughly 1 to 3 new stars per year, though this rate has varied substantially over the galaxy's history. The fraction of stars with planets, the second term, has been transformed by the Kepler mission and subsequent surveys. We now know that planets are nearly ubiquitous around stars of all types. The average is somewhere around 1 planet per star and probably more. The fraction of planets in habitable zones is also better understood, with current estimates suggesting that roughly 20% of Sun-like stars host an Earth-sized planet at a distance where liquid water could exist. These first few terms alone produce staggering numbers. If we accept conservative estimates for the early factors, the galaxy contains somewhere between 10 billion and 40 billion potentially habitable planets. This is the first stage of the calculation, and it is firmly grounded in observational astronomy. The numbers are not speculative. They are derived from measurements of real stars and real planets, extrapolated across the broader population of the galaxy. The implications, even before we consider biology, are enormous. Habitable real estate is not in short supply. The cosmos provides abundant opportunities for life to emerge. The biological terms of the equation are where uncertainty begins to expand dramatically. The fraction of habitable planets where life actually arises is perhaps the most contested factor. We have only one data point to work with, our own planet, and a single data point is statistically useless. On Earth, life appears to have emerged remarkably quickly after conditions became suitable. The oldest confirmed microfossils date to around 3.5 billion years ago, and there is chemical evidence suggesting life may have existed even earlier. Given that Earth itself is only about 4.5 billion years old, and the first several hundred million years were too hostile for life, this means that life appeared almost as soon as it became possible. Some biologists interpret this rapid emergence as evidence that abiogenesis, the spontaneous origin of life from non-living chemistry, is a probable outcome wherever the conditions are right. The argument is that if it took only 100 million years for life to arise on Earth, then the process cannot be exceedingly rare. If it required a 1 in a trillion accident, we would not expect to see it happen so quickly. Others counter that this reasoning suffers from observational bias. We can only ask the question because we exist, and we can only exist on a planet where life arose. The early emergence might be a fluke, and we are simply observing the rare success rather than the countless failures. The next term, the fraction of life-bearing planets where intelligence evolves, is even more uncertain. On Earth, complex multicellular life took billions of years to develop after the first microbes appeared. Intelligence of the kind capable of building radio telescopes appeared only in the last few 100,000 years, an evolutionary eye blink. Whether intelligence is a probable outcome of evolution or a rare contingent accident remains one of the deepest questions in biology. Some evolutionary biologists, including the late Stephen Jay Gould, argued that intelligence is highly contingent, the result of a long chain of accidents that would not be repeated if evolution were rerun from the beginning. Others, including Simon Conway Morris, argue that intelligence is a convergent feature that evolution tends to produce when given enough time, much like eyes or wings have evolved independently many times. The technological term adds another layer of uncertainty. Even if intelligence evolves, it does not necessarily produce a civilization capable of interstellar communication. Many intelligent species on Earth, including dolphins, elephants, and various corvids, show clear signs of cognitive sophistication but have never developed technology. Humans appear to be the only species on Earth that has built radio transmitters, and we did so only in the last century. Whether this is a typical outcome or a freak event is impossible to determine from a sample size of one. And then there's the final term, the lifetime of a technological civilization. This is perhaps the most haunting factor in the equation. Drake originally suggested that civilizations might last only a few hundred years before destroying themselves through warfare, environmental collapse, or runaway technology. If this estimate is correct, then the number of currently detectable civilizations collapses dramatically. Even if every other term in the equation is favorable, a short civilizational lifetime means that the galaxy contains only a handful of active broadcasters at any given moment, scattered across vast distances with little chance of overlap. The silence becomes explainable not as the absence of civilizations, but as the result of their brevity. When the full equation is calculated using various plausible values, the results span an extraordinary range. Optimistic estimates suggest the galaxy contains tens of thousands or even millions of technological civilizations. Pessimistic estimates suggest we may be alone. The wide range reflects the deep uncertainty about the biological and sociological terms. The equation does not resolve the Fermi Paradox. It clarifies why the paradox is so difficult to resolve. Different reasonable assumptions about a few key parameters produce wildly different conclusions about whether the universe should be full of voices or silent as a tomb. What the Drake equation does accomplish is forcing a structured analysis of the problem. It separates the question into measurable components. It allows new data to refine specific terms while leaving others intact. As exoplanet science has advanced, the early terms have become much more favorable. We now know that habitable planets are common. This pushes the calculation toward higher numbers of potential civilizations and deepens the paradox. The more habitable real estate we discover, the louder the silence becomes. In recent years, scientists have proposed extensions and modifications to the Drake equation. Some have added terms for the probability that a civilization actively seeks contact, the probability that its signals overlap in time with ours, and the probability that we are looking in the right places with the right instruments. Others have proposed entirely new equations, including the Seeger equation for biosignatures and the Sandberg, Drexler, and Ord analysis that uses probability distributions rather than point estimates for each term. Their work, published in 2018, concluded that under reasonable uncertainty, there is a substantial probability that humanity is alone in the observable universe, even given favorable conditions for life. This statistical refinement is important, but it does not eliminate the paradox. It merely sharpens the question. If we are alone, why are we alone? What barrier or filter prevents the otherwise inevitable spread of intelligence through the cosmos? And here, we arrive at the next critical concept, one that has emerged as perhaps the most disturbing possible answer to Fermi's question. The great filter is the idea that somewhere between the formation of a star and the rise of a galaxy-spanning civilization, there is a step so improbable, so difficult, or so destructive that almost no candidate ever crosses it. The question of where that filter lies and whether humanity has already passed it or still faces it ahead is one that becomes especially urgent when we consider what might be hiding in the declassified files. The concept of the Great Filter was formalized in 1996 by Robin Hanson, an economist at George Mason University, who turned his attention to the implications of the Fermi Paradox. Hanson observed that the silence of the cosmos required an explanation, and the most parsimonious explanation was that somewhere along the long developmental path from lifeless chemistry to interstellar civilization, there exists a barrier so improbable that almost nothing crosses it. He called this barrier the Great Filter. The framework reorganizes the Drake equation by asking not whether life is common, but whether the transitions between developmental stages are common. Consider the chain of events that produces a detectable civilization. A habitable planet must form. Simple life must emerge from non-living chemistry. That simple life must evolve into complex cells. Complex cells must aggregate into multicellular organisms. Multicellular life must produce nervous systems. Nervous systems must yield intelligence. Intelligence must develop tool use. Tool use must develop into technology. Technology must reach the point of interstellar communication or travel. And finally, the resulting civilization must persist long enough to be detected by neighbors elsewhere in the galaxy. Each of these transitions represents a potential filter. Each could be the barrier that explains the silence. If the great filter lies in our past, then the implication is reassuring. It means that the difficult step has already been taken. Perhaps abiogenesis is extraordinarily rare. Perhaps the transition from prokaryotic to eukaryotic cells, which on Earth required nearly 2 billion years and may have involved a singular and unlikely merger of two microorganisms, is the bottleneck. Perhaps complex animal life is the rare event. In any of these cases, the conclusion is that life like us, having already crossed the filter, is essentially home free. The galaxy is quiet because few species have made it this far. Those that have should expect a long and successful future. But if the great filter lies in our future, the implication is grim. It means that some catastrophe awaits all technological civilizations, including ours. Nuclear war, ecological collapse, artificial intelligence gone wrong, biological pandemics engineered by malicious actors, the emergence of self-destructive social patterns, or perhaps some unknown danger that all civilizations encounter once they reach a certain level of capability. In this scenario, the silence is a warning. Every species that came before us hit the same wall, and so will we. Hanson's analysis carried a sobering corollary. The discovery of life beyond Earth would actually be bad news for humanity. If we find microbial life on Mars or chemical signatures of biology in the atmosphere of an exoplanet, it would mean that abiogenesis is not the filter. The barrier lies somewhere else, somewhere closer to our current developmental stage. The more steps we observe other civilizations completing without success, the more likely it becomes that the filter still awaits us. This is sometimes called the Great Filter Anxiety. Each discovery of extraterrestrial life, particularly intelligent or technological life, shifts the probability that humanity faces an existential barrier in its near future. This framework gives us a tool for thinking about the declassified files in a particular way. If unidentified aerial phenomena represent technology from civilizations that successfully crossed every developmental stage, then those civilizations have passed every filter that might apply to us. They have survived their nuclear age. They have managed their environmental crises. They have not destroyed themselves through artificial intelligence or biotechnology. They have endured for long enough to reach our solar system. From the perspective of the Great Filter, their presence would suggest that the filter is not insurmountable. Some species do make it through, but this optimistic reading has a darker counterpart. If advanced civilizations exist and have chosen not to make open contact with humanity, the question becomes why. Several explanations have been proposed, each with disturbing implications. They may be observing us during a critical period of our development, much as biologists observe an animal population without intervening. They may be waiting to see whether we cross our own great filter. They may have judged us not ready, not worthy, or not safe to contact. They may have determined that contact itself is the danger, the trigger that pushes emerging civilizations over the edge into self-destruction. The structure of the Great Filter hypothesis also illuminates a particular puzzle in the history of life on Earth. The transition from simple prokaryotic cells to complex eukaryotic cells took an extraordinarily long time. For roughly 2 billion years after life first appeared, the Earth was populated by nothing more sophisticated than bacteria and archaea. Then, in what appears to have been a single evolutionary event, a bacterium was engulfed by another microorganism, and instead of being digested, became the ancestor of mitochondria. This endosymbiotic merger created the first eukaryotic cell, the ancestor of all complex life on Earth. Every plant, animal, and fungus alive today descends from that one event. Some biologists have argued that this transition may have been a one-off accident, a freak occurrence that required precisely the right conditions and the right organisms in the right configuration. If true, it would mean that complex life is vanishingly rare in the cosmos. Most habitable planets would remain microbial worlds forever, their oceans and atmospheres teeming with simple cells that never make the leap to complexity. The galaxy could be full of life, but almost all of it would be invisible at interstellar distances. Intelligence would be the rare exception, not the rule. If this is the Great Filter, then humanity has already crossed it. We are the descendants of that improbable cellular merger, and we should expect to be extremely rare in the cosmos. The silence is explained not by destruction or self-limitation, but by the simple fact that almost no other planet ever produces creatures complex enough to ask the question. Under this scenario, the appearance of advanced technology in our skies would be especially significant. It would suggest that whatever filter we crossed, others have crossed it too, and perhaps the universe is not as empty as the standard analysis suggests. Other candidates for the Great Filter have been proposed at various points in evolutionary history. Some researchers point to the development of meiotic sexual reproduction, which allows genetic recombination and the rapid evolution of complex traits. Others highlight the emergence of language and culture, which allow knowledge to accumulate across generations rather than being lost with each death. Still others focus on the development of writing, mathematics, or scientific methodology, each of which represents a discontinuous leap in cognitive capability. Any of these could be the rare event that separates emergent biology from technological civilization. But the most disturbing versions of the Great Filter hypothesis focus on the future rather than the past. Nick Bostrom, the philosopher at Oxford University who has written extensively on existential risk, has argued that the absence of evidence for extraterrestrial civilizations should make us cautious about our own prospects. If the filter lies behind us, the cosmos should be silent in a particular way, with no signs of failed civilizations. If the filter lies ahead, we should expect to see ruins. We should see the remains of civilizations that almost made it, the Dyson swarms that were never completed, the colonies that died young, the megastructures abandoned mid-construction. The absence of such ruins, while not definitive, suggests that either civilizations are extremely rare or they fail in ways that leave no detectable traces. Bostrom's argument is sobering because it forces us to consider what kind of failure would be catastrophic enough to erase all traces. A civilization that destroyed itself through nuclear war would leave radioactive isotopes, atmospheric scars, and possibly orbital debris. A civilization that collapsed through ecological mismanagement would leave climatic and geological signatures. A civilization that simply went extinct through some natural cause would leave fossils and ruins. But a civilization that was deliberately erased, perhaps by another civilization or by some emergent threat such as a runaway artificial intelligence, might leave no trace at all. The clean silence we observe is most easily explained by clean filters, the kind that remove not just civilizations but evidence of their existence. This line of reasoning connects directly to the declassified phenomena. If something is operating in our atmosphere with technology beyond our current capabilities, and if that something has been present for decades or longer without making open contact, then the question of motive becomes pressing. Are they waiting for us to cross our own filter? Are they preventing certain technologies from being developed? Are they part of the filter itself, the mechanism by which emerging civilizations are kept from becoming threats? Each possibility carries its own implications for our future. The Great Filter Framework also explains why the declassification of military files has become such a sensitive matter. If the phenomena documented in those files represent genuine evidence of advanced civilizations, then the implications go far beyond curiosity. They suggest that we are not alone, that the filter is crossable, and that the silence of the cosmos is more complicated than it appears. They also suggest that we are being observed, possibly by entities with the capability to affect our development. The political and social implications of such a confirmation are profound. It is no surprise that governments have approached the topic with extreme caution, yet the documents have begun to surface. Programs once denied have been acknowledged, pilots once dismissed have been believed, radar data once classified has been released to the public. The question is no longer whether unidentified aerial phenomena exist, but what they are and what they mean. To understand the modern state of the inquiry, we must go back to the moment when the United States government first began systematically investigating these phenomena, to a program that began under the cloud of the Cold War and ended with a public dismissal that hid more than it revealed. The official American investigation of unidentified aerial phenomena did not begin as a single coherent program. It evolved through a series of overlapping projects, each with its own scope, methodology, and conclusion. The first formal investigation, Project Sign, was established by the United States Air Force in 1947, the same year as the Kenneth Arnold sighting and the Roswell incident that would later become the most famous case in the field. Project Sign was based at Wright-Patterson Air Force Base in Ohio, and was tasked with collecting and analyzing reports of flying discs and other unusual aerial objects. Its existence was classified, and its findings remained restricted for decades. Project Sign was succeeded by Project Grusch in 1949, which adopted a more skeptical institutional stance. The change in name reflected a change in attitude. Grusch began with the working assumption that the reports were either misidentifications, hoaxes, or psychological phenomena. The investigation became less rigorous and more dismissive. Internal documents from this period show that some intelligence officers were frustrated by the lack of serious scientific analysis, while others believed that the public should be reassured that there was nothing to investigate. The tension between these two camps would define the American approach to the subject for the next half-century. Project Blue Book was launched in 1952 taking over from Grusch with a broader mandate and a longer institutional life. Over the next 17 years, Blue Book would investigate 12,618 reported sightings. The program was headquartered at Wright-Patterson and staffed by a small team of officers and analysts. Its public face was Captain Edward Ruppold, who served as the first director and is credited with coining the term unidentified flying object, or UFO, to replace the more sensational term flying saucer. Ruppold approached the work with apparent seriousness and wrote a book after his retirement that conveyed his belief that some reports represented genuinely unexplained phenomena worthy of further study. The methodology of Project Blue Book was simple in principle but limited in practice. Reports came in from military personnel, commercial pilots, police officers, and civilians. Each report was logged, classified, and evaluated against possible mundane explanations. Investigators considered weather balloons, aircraft, astronomical phenomena, optical illusions, and atmospheric effects. Reports that could be explained were closed. Reports that could not be explained were placed in the unidentified category. By the time the program was officially terminated in 1969, approximately 700 of the 12,618 cases remained unexplained. That number is significant. 700 cases, drawn from observers who were often trained military personnel using calibrated instruments, could not be reconciled with any conventional explanation. The official conclusion of Project Blue Book, however, was that there was no evidence of extraterrestrial technology, no threat to national security, and no reason to continue the investigation. The unexplained cases were attributed to insufficient data, the implication being that with more information, they too would resolve into conventional phenomena. The program was closed, the files were archived, and the public was told that the matter had been settled. The closure of Project Blue Book was driven in large part by the Condon Report, formerly titled The Scientific Study of Unidentified Flying Objects, which was conducted by physicist Edward Condon at the University of Colorado between 1966 and 1968. The report was commissioned by the Air Force and intended to provide an authoritative scientific evaluation of the subject. Its conclusions were used to justify the termination of Blue Book and the official disengagement of the United States government from the topic. Condon concluded that further study of UFOs was unlikely to be scientifically productive and recommended that no public funds be allocated to such investigations. The Condon Report was controversial from the moment it was published. Critics pointed out that its conclusions did not match the contents of its own case studies. Of the cases analyzed by Condon's team, roughly 30% were left unexplained. Several of those cases involved highly credible witnesses, multiple corroborating observers, and physical evidence such as radar tracks or photographs. The report's own data suggested that something genuinely anomalous was occurring, but its summary conclusions framed those anomalies as unworthy of further investigation. Some scientists who had participated in the study later expressed disagreement with the report's framing, arguing that Condon had reached his conclusions before the evidence was fully analyzed. What the public did not know at the time, and what would only become clear decades later, was that Project Blue Book was never the only investigation. Other programs, more classified and more focused, operated in parallel. The Central Intelligence Agency had its own analysts working on the subject. The Defense Intelligence Agency maintained files. Various military branches conducted their own internal investigations of incidents involving their personnel. The closure of Blue Book did not represent the end of government interest. It represented the end of public government interest, while the actual research continued behind layers of classification. This duality has been confirmed by documents released under the Freedom of Information Act and through subsequent declassification efforts. Memos from CIA officials in the 1950s and 1960s discussed the topic with seriousness that does not match the public dismissal. Internal Air Force documents reference investigations of incidents involving nuclear weapons facilities, sensitive military installations, and incursions over restricted airspace. The picture that emerges from these documents is not one of casual interest, but of sustained concern. Something was happening, and the institutions tasked with national security were paying close attention, even as they assured the public that nothing was happening at all. One of the most striking examples of this disconnect involves a series of incidents at American nuclear missile installations during the Cold War. Multiple reports, since corroborated by retired Air Force officers, describe unidentified objects hovering over launch facilities and, in some cases, apparently interfering with the missiles themselves. The most well-known incident occurred at Malmstrom Air Force Base in Montana in March of 1967. According to the accounts of officers who were on duty that night, a glowing object was observed hovering over the base. Shortly thereafter, multiple intercontinental ballistic missiles were taken offline in a manner that could not be readily explained by standard equipment failures. Captain Robert Salas, one of the officers on duty in the launch control facility that night, has spoken publicly about the incident in subsequent decades. He described receiving reports from security personnel above ground of an oval-shaped object hovering near the front gate. While these reports were still coming in, the missiles in his flight began going offline one after another, displaying fault codes that should not have been possible to trigger simultaneously through any known mechanism. The base was eventually placed on alert, and the incident was investigated by Air Force authorities. The resulting report was classified, and Salas was reportedly instructed not to discuss what had happened. Similar incidents have been reported at other nuclear facilities, including bases in North Dakota, Wyoming, and overseas locations. The pattern, if real, suggests that whoever or whatever was operating in our airspace had a particular interest in nuclear weapons. Whether this interest reflected concern, curiosity, or something else entirely is impossible to determine from the available evidence. But the existence of such incidents, now corroborated by multiple witnesses speaking publicly after decades of silence, suggests that the official Blue Book conclusion of no national security implications was, at best, incomplete. The discrepancy between the public position and the internal reality has been one of the central features of the modern declassification effort. As documents have been released and former officials have spoken out, a clearer picture has emerged of an institutional culture that compartmentalized information about unidentified aerial phenomena with extreme strictness. Programs operated under code names that were not even acknowledged to exist. Personnel were sworn to secrecy under penalties that included loss of clearance, prosecution, or worse. The information that reached the public was carefully filtered to maintain plausible deniability about the scope and seriousness of the inquiry. This pattern of compartmentalization is significant because it shapes how we should interpret the declassified files that have emerged in recent years. When a document is released, the question is not only what it contains, but what it implies about what remains classified. A program that is now publicly acknowledged was almost certainly preceded by classified work of a similar nature. A pilot who is now permitted to speak almost certainly observed things that he is still not permitted to discuss. The visible portion of the iceberg suggests a much larger structure beneath the surface, and the contours of that hidden structure can be inferred from the shape of what has been revealed. In the decades following the closure of Project Blue Book, the official position of the United States government remained that there was no ongoing investigation, no credible evidence of extraterrestrial technology, and no national security interest in the subject. This position was maintained through multiple administrations across both political parties, and despite occasional incidents that would have warranted public acknowledgement if the official position had been honest, pilots continued to encounter unexplained objects. Radar systems continued to track unidentified targets. Sensors at sensitive facilities continued to record anomalous activity. None of this was acknowledged publicly, and the documentary record continued to accumulate in classified files. What changed, and what would eventually force the conversation into the open, was a slow erosion of the institutional consensus. Officials who had worked on classified programs began to retire and speak out. Documents that had been suppressed for decades began to leak. Journalists began to investigate. And finally, in 2017, a series of revelations would bring the subject back into mainstream discourse and force the government to acknowledge what it had spent half a century denying. The story of how those hidden documents began to surface is the story of how a buried investigation conducted in the shadows of the national security state was finally pulled into the light. The path from official denial to public acknowledgement was neither straight nor swift. For decades after the closure of Project Blue Book, the topic of unidentified aerial phenomena was treated within official channels as a closed matter. Journalists who pursued it were often marginalized. Scientists who took it seriously risked their reputations. The subject was relegated to the fringes of public discourse, the territory of tabloid newspapers and late-night radio shows. And yet, behind this curtain of dismissal, work continued. The institutional memory of the phenomenon never disappeared. It simply went deeper underground. The first significant crack in the wall came not from a leak or a hearing, but from a wealthy private citizen with the resources to investigate independently. Robert Bigelow, a hotel magnate and aerospace entrepreneur, had a long-standing interest in unidentified aerial phenomena and the related question of consciousness and paranormal experience. In the 1990s, Bigelow funded an organization called the National Institute for Discovery Science, which conducted private investigations of various anomalous events. Among its projects was the study of a property in northeastern Utah known as the Skinwalker Ranch, where unusual phenomena had been reported for decades. The scientific value of this work has been debated, but it established a precedent of private investment in serious investigation of phenomena that the government had publicly disavowed. Bigelow's interests would eventually intersect with those of Senator Harry Reid of Nevada, the powerful Senate Majority Leader who shared a personal fascination with the subject. Reid had access to the classified world that ordinary citizens did not. Through conversations with Bigelow and others, he became convinced that the government was failing to seriously investigate a phenomenon that potentially had national security implications. In 2007, with the support of fellow Senators Daniel Inouye and Ted Stevens, Reid arranged for the establishment of a classified program within the Defense Intelligence Agency. The program was called the Advanced Aerospace Threat Identification Program, abbreviated as AATIP, and it was funded at approximately $22 million over 5 years. AATIP operated almost entirely in secret. Its existence was known to only a small number of officials. Its funding was buried within the larger Defense Intelligence Agency budget, under categories that did not draw attention. Its mission was to investigate reports of unidentified aerial phenomena, particularly those involving military personnel and sensitive installations, and to assess any potential threat or technological implications. The program was led for several years by Luis Elizondo, a career intelligence officer with a background in counterintelligence and special operations. Elizondo would later become a central figure in the public emergence of the story. The work of AATIP included the collection of military reports, the analysis of censored data, the interviewing of witnesses, and the commissioning of research papers on speculative physics relevant to the observed phenomena. Some of these research papers, prepared by independent contractors and academic consultants, address topics such as warp drive theory, metamaterials, anti-gravity propulsion, and the manipulation of space-time. The papers were not endorsed positions of the United States government, but their commissioning indicated that the program took seriously the possibility that the observed phenomena involved physics beyond current human understanding. The funding for AATIP ran out in 2012, but according to subsequent reporting and statements by Elizondo, the work continued in some form under other auspices and with personnel who continued to investigate cases on what amounted to volunteer time. Elizondo himself remained at the Department of Defense, continuing to receive and analyze reports. By 2017, however, he had grown frustrated with what he perceived as institutional resistance to taking the subject seriously. He resigned from his position in October of that year, citing a desire to bring greater public attention to the issue. What happened next changed the trajectory of the entire field. In December of 2017, the New York Times published a long article titled "Glowing Auras and Black Money: The Pentagon's Mysterious UFO Program." Co-written by Helene Cooper, Ralph Blumenthal, and Leslie Keane, the article revealed the existence of AATIP, described its activities, and included the first public release of military footage showing unidentified aerial phenomena. The footage, captured by Navy F-18 fighter jets, showed objects performing maneuvers that the pilots could not explain. Within 24 hours of publication, the article had become front-page news around the world. The significance of this moment cannot be overstated. The New York Times is one of the most respected newspapers in the world. Its editorial standards are stringent. The fact that the paper had committed its credibility to a story about a classified Pentagon program investigating unidentified aerial phenomena represented a profound shift in how the subject would be treated. The fringe had become mainstream. The denied had become acknowledged, and the question of what these phenomena actually were had become a legitimate topic of public discussion. The footage released alongside the Times article quickly became iconic. One clip, known as the FLIR 1 video, showed a small white object moving against a blue background, observed through the infrared targeting pod of an F-18. The object appeared to rotate and accelerate in ways that were difficult to reconcile with conventional aircraft. Another clip, known as the gimbal video, showed an oval-shaped object that appeared to rotate on its central axis while moving against the wind, accompanied by the audible exclamations of the pilots watching it on their displays. A third clip, known as the Go Fast video, showed a small object moving rapidly above the surface of the ocean. These three videos became the public face of the phenomenon and the basis for years of subsequent analysis and debate. The Department of Defense initially declined to comment on the videos, but pressure mounted as additional reporting confirmed their authenticity. In April of 2020, after years of unofficial leaks, the Pentagon formally acknowledged the videos as genuine and confirmed that they showed unidentified aerial phenomena that the Navy had been unable to identify. The acknowledgement was historic. For the first time, the United States government officially confirmed that its military had encountered objects in the sky that defied conventional explanation. The position that had been maintained since the closure of Project Blue Book, that there was nothing to investigate, was no longer tenable. The pace of disclosure accelerated from this point forward. In June of 2020, the Senate Intelligence Committee included in its annual Intelligence Authorization Bill a provision requiring the Director of National Intelligence and the Secretary of Defense to provide a public report on unidentified aerial phenomena. The provision was included at the urging of Senator Marco Rubio, who had become chairman of the committee and had taken a serious interest in the subject. The resulting report, delivered to Congress in June of 2021, was the first official public assessment of unidentified aerial phenomena since the Condon Report more than 50 years earlier. The 2021 report was a measured document. It analyzed 144 cases of unidentified aerial phenomena reported by military personnel between 2004 and 2021. Of these, only one was confidently identified as a deflating balloon. The remaining 143 were classified as unidentified. The report acknowledged that some of these phenomena appeared to demonstrate flight characteristics that were difficult to explain with current understanding. It did not conclude that the phenomena were extraterrestrial. It also did not rule out that possibility. The conclusions were framed in terms of intelligence gaps, recommending further investigation and improved data collection. What the report did not say was perhaps as important as what it did say. It did not claim that the phenomena were definitely human in origin. It did not claim that they were definitely natural. It did not provide reassurance that there was nothing of concern. Instead, it presented a careful, restrained acknowledgement that something real was happening in American airspace, that the military did not understand it, and that the question warranted continued, serious investigation. For those who had spent decades pushing for transparency, the report was both a vindication and a disappointment. It confirmed that the topic was legitimate, but it left almost every substantive question unanswered. The institutional response continued to evolve. In 2022, the Department of Defense established a new organization called the All-Domain Anomaly Resolution Office, or ARO, to consolidate the investigation of unidentified aerial phenomena across the military and intelligence community. The new office was given broader authority than its predecessors, including responsibility for investigating phenomena observed underwater and in space, not just in the atmosphere. The change in terminology reflected the expanding scope of the inquiry. The phenomena being investigated were no longer described as unidentified flying objects, but as unidentified anomalous phenomena, a broader category that acknowledged the variety of environments in which they had been observed. The establishment of ARO was accompanied by additional legislative action. Congress passed provisions requiring secure reporting channels for military personnel who observed unidentified phenomena, mandated regular reports to congressional oversight committees, and protected whistleblowers who came forward with classified information about historical programs. These provisions reflected a growing recognition that decades of compartmentalization had created an environment in which legitimate information might be trapped within classified silos, inaccessible even to senior officials who had a need to know. Among the most consequential of these provisions was a whistleblower protection clause embedded in the National Defense Authorization Act. The clause provided a legal framework for individuals with knowledge of classified programs related to unidentified aerial phenomena to report that information to congressional intelligence committees without facing legal retaliation. This provision opened the door for testimony that would otherwise have been impossible to obtain. And in the summer of 2023, that door was opened wider than anyone had expected by a former intelligence officer named David Grusch, whose claims would push the conversation into territory that no one in official Washington had previously been willing to enter. David Charles Grusch was not the kind of figure who could be easily dismissed. He had served in the United States Air Force as an intelligence officer with a focus on Afghanistan operations and had been recognized with awards for his work in combat zones. He had subsequently served as a representative to the National Reconnaissance Office on the Unidentified Aerial Phenomena Task Force, and later as the National Geospatial Intelligence Agency's representative to the same task force. He had held high-level security clearances. He had been entrusted with access to some of the most sensitive, compartmented information in the American intelligence community. He was, by every conventional measure, a credible insider. In June of 2023, Grusch went public with allegations that would reshape the entire conversation. In an interview with the journalist Ross Coulthart, published on the news site The Debrief, Grusch claimed that the United States government had been running a multi-decade program to recover crashed or otherwise acquired non-human craft. He further claimed that the program had recovered biological remains of the operators of some of these craft. He stated that the information had been illegally withheld from Congress, that the program operated outside normal oversight structures, and that he was making his disclosures through formally protected whistleblower channels. The allegations were extraordinary in their scope. Grusch did not claim to have personally seen recovered craft or biological materials. He claimed instead to have spoken with multiple credentialed individuals who had direct knowledge of the program and to have reviewed documentation supporting their accounts. He had submitted formal complaints to the Department of Defense Inspector General, who had reportedly found his complaints credible and urgent enough to warrant referral to congressional oversight committees. The legal framework established by the whistleblower protection provisions allowed him to make his disclosures publicly while maintaining the legal protections of his classified status. The public response to Grusch's allegations was initially muted in mainstream media, despite the extraordinary nature of the claims. Most major outlets covered the story but framed it with significant skepticism, noting that Grusch's claims had not been independently verified and that he had not provided documentary evidence to support them. Critics pointed out that the claims, while detailed, relied entirely on his characterization of conversations with unnamed sources. Without corroborating documentation, the allegations remained allegations rather than confirmed facts. But Grusch's claims gained traction within Congress in a way that previous similar claims had not. Members of both political parties expressed interest in hearing his testimony. The House Oversight Committee scheduled a hearing for July 26th of 2023, titled Unidentified Anomalous Phenomena: Implications on National Security, Public Safety, and Government Transparency. The hearing would feature testimony from Grusch, alongside two former Navy pilots who had encountered unidentified phenomena during their service. The witnesses would testify under oath with the full legal weight that such testimony carries. The hearing was historic. For the first time, a witness with high-level intelligence clearances testified before Congress about the existence of a non-human technology recovery program. Grusch made his claims under oath, stating that he had been informed by individuals with direct knowledge that the United States government possessed craft of non-human origin and biological remains of their occupants. He stated that the program had been illegally hidden from congressional oversight, that whistleblowers who had attempted to come forward had faced retaliation, and that he himself had experienced threats during the course of his investigation. He was careful to note that he could not discuss specific classified details in a public setting, but had provided fuller information to the relevant committees in classified session. The testimony of the other witnesses provided crucial context. Ryan Graves, a former Navy F-18 pilot, described regular encounters with unidentified aerial phenomena during training exercises off the eastern coast of the United States. He testified that the encounters had been so common that they were essentially treated as routine, and that the pilots involved had been frustrated by the lack of institutional support for reporting and investigating what they were seeing. Graves emphasized the stigma that had attached to discussing the phenomena, a stigma that he and his colleagues believed had created genuine safety hazards by discouraging proper reporting. David Fravor, the retired Navy commander who had been the lead pilot in the famous tic-tac encounter off the coast of San Diego in 2004, also testified. Fravor described his encounter in detail, explaining that he had observed an object roughly the size of an F-18 hovering above the water with no visible means of propulsion, no exhaust signature, and no infrared heat trail. The object had then accelerated to supersonic speeds in a fraction of a second, performing maneuvers that Fravor stated were not possible for any aircraft he was familiar with. His testimony, which had been corroborated in earlier interviews by other pilots and radar operators present during the incident, provided one of the most credible eyewitness accounts in the public record. The hearing was widely viewed and widely covered, but its conclusions were limited by the constraints of the public format. Many of the most consequential questions could not be answered without disclosing classified information. Grusch repeatedly indicated that he could provide more detailed information in classified session, and the committee members who had access to those sessions reportedly emerged from them with serious concerns about what they had learned. Senator Marco Rubio, who had access to classified briefings on the topic, stated publicly that he had heard from multiple credentialed individuals making claims similar to those of Grusch, and that the consistency of those accounts deserved serious investigation. The aftermath of the hearing produced both progress and frustration. On the legislative side, the National Defense Authorization Act for the fiscal year 2024 included expansive new provisions related to unidentified anomalous phenomena. A senior version of the bill, drafted by Senator Chuck Schumer and modeled on the President John F. Kennedy Assassination Records Collection Act, would have established a Federal Records Review Board with authority to declassify documents related to unidentified anomalous phenomena, and would have invoked eminent domain authority over any recovered materials held by private contractors. The provisions were ultimately weakened during the conference process, with the most aggressive elements removed, but the final bill still included significant new authorities for transparency and disclosure. The weakening of the Schumer Amendment was itself instructive. Reporters who covered the legislative process described intense lobbying from defense industry interests and from elements within the intelligence community to remove the most stringent disclosure requirements. The fact that such lobbying occurred at all was taken by many observers as indirect confirmation that there was indeed something to hide. If the topic were truly the empty matter that official statements had long suggested, there would be no need for elaborate efforts to prevent disclosure. The intensity of the resistance to transparency was, in itself, a form of evidence. Throughout this period, Additional whistleblowers reportedly came forward through protected channels, providing testimony to congressional committees that has not yet been made public. The all-domain anomaly. Resolution Office continued its investigations, producing periodic reports that cataloged ongoing observations. The number of reported incidents grew rapidly, partly as a result of improved reporting channels, and partly as a reflection of what may be a genuine increase in the frequency of observations. By 2024, AARO had received reports of more than 1,000 incidents, a substantial increase over the historical baseline. The broader implications of this period of disclosure are still being processed. The Grusch testimony and the surrounding congressional activity established several important precedents. The phenomena being investigated were no longer treated as fringe curiosities but as matters of serious national security concern. The institutional resistance to transparency was acknowledged as a problem requiring legislative remedy. The existence of compartmented programs operating outside normal oversight structures was treated as a credible possibility worthy of investigation. And the question of whether any of the phenomena under investigation might be of non-human origin was, for the first time, treated as a question that the government was obligated to either confirm or deny. What the government has not done, despite the unprecedented level of public discussion, is provide a definitive answer. The official position remains that some phenomena are unexplained, that investigation is ongoing, and that no conclusive determination has been made regarding their origin. This carefully neutral stance has its own implications. A government that had decisively concluded that the phenomena were terrestrial, in origin, would presumably say so. A government that had decisively concluded that they were extraterrestrial would face enormous pressure to disclose. The continued maintenance of an intermediate position in which the question is acknowledged but not answered suggests either that the answer is genuinely unknown or that political and institutional considerations make disclosure of the known answer impossible. This is the context in which the modern reader must consider the question of the Fermi Paradox. If the silence is being broken, even partially, by phenomena occurring in our own atmosphere, then the framework for understanding cosmic isolation must be reconsidered. The mathematics that suggested we should be alone, or at least undisturbed, must be reconciled with sensor data showing otherwise. The next step in this reconciliation requires a closer look at the most specific and well-documented of the modern encounters, an incident off the coast of Southern California in 2004 that has come to be regarded as the gold standard of unidentified aerial phenomena cases, a case in which trained military pilots in calibrated aircraft observed something that simply should not have been possible. The tic-tac encounter took place between November 10th and 14th of 2004 off the coast of Southern California in the operational area of the Nimitz Carrier Strike Group. The strike group was conducting a routine pre-deployment workup exercise, a complex multi-ship operation designed to prepare the carrier and its escorts for an upcoming deployment to the Persian Gulf. The exercise involved multiple naval vessels, dozens of aircraft, and the kind of integrated radar and sensor coverage that represents the leading edge of military situational awareness. It is precisely because of this density of sensor coverage that the events that followed are so well documented and so difficult to dismiss. The first anomalies were detected by the USS Princeton, a Ticonderoga-class guided missile cruiser equipped with the SPY-1B phased array radar system. The Princeton was operating as the Air Defense Command ship for the strike group, with primary responsibility for tracking aerial contacts in the surrounding airspace. The SPY-1B was, at the time, one of the most sophisticated radar systems in operation, capable of tracking hundreds of targets simultaneously across multiple frequency bands. The system had recently been upgraded, and the radar operators were among the most skilled in the Navy. Over a period of several days, the Princeton began tracking objects that displayed flight characteristics inconsistent with any known aircraft. The objects, designated as anomalous aerial vehicles in the eventual reporting, would appear at altitudes of around 80,000 feet, far above the operational ceiling of conventional aircraft. They would then descend rapidly to altitudes near sea level, covering a vertical distance of 15 miles in a matter of seconds. They would hover stationary for extended periods, then accelerate and disappear. The objects did not match the radar signature of any aircraft in the strike group's database. They did not respond to standard interrogation protocols. They did not appear on any flight plan or transponder system. The senior chief radar operator on the Princeton, Kevin Day, has spoken extensively in subsequent years about what he and his team observed. According to Day, the radar tracks were of such unusual character that the operators initially suspected a malfunction. They performed standard diagnostic procedures on the radar system, verified its calibration, and confirmed that the tracks were consistent across multiple sensor passes. They were not artifacts of the equipment. They were genuine returns from physical objects in the airspace. The objects were also detected by other ships in the strike group and by E-2 Hawkeye airborne early warning aircraft operating overhead, providing independent confirmation through multiple sensor platforms. On November 14th, the decision was made to intercept one of these objects. 2 F-18 Super Hornet fighter jets were vectored to the location where the Princeton's radar was tracking an anomalous contact. The lead pilot was Commander David Fravor, an experienced fighter pilot and the commanding officer of his squadron. His wingman was Lieutenant Commander Jim Slate. Both pilots had been flying for many years and were considered among the most capable aviators in the Navy. They had been briefed that something unusual had been appearing on radar, but they had not been given specific expectations about what they might encounter. As they approached the coordinates provided by the Princeton, Fravor and Slate observed disturbance on the surface of the ocean below. The water appeared to be churning, as though something just below the surface was creating a turbulent area roughly the size of a Boeing 737. Above this disturbance, hovering at an altitude of approximately 20,000 feet, was an object. Fravor would later describe it as resembling a tic-tac mint, an elongated white shape roughly 40 feet long, with no wings, no exhaust, no rotors, and no visible means of propulsion. It hung in the air over the disturbed water, moving in small, erratic patterns. Fravor decided to investigate more closely. He began a descending spiral toward the object, intending to get a closer look. As he did so, the object appeared to mirror his movements, ascending toward him in a similar spiral pattern. The two of them, Fravor in his F-18 and the unknown object, were converging on each other in a controlled approach. As they came within close range, the object suddenly accelerated, rotated to a horizontal orientation, and moved laterally at extraordinary speed. Fravor would later estimate that the object traveled what looked like a few miles in less than a second, which would imply a velocity of several thousand miles per hour, achieved without any visible acceleration phase and without producing any sonic boom. The object disappeared from visual contact almost immediately. Fravor radioed his observations to the Princeton, requesting confirmation of the radar track. The Princeton confirmed that they had lost contact with the original target, but had detected another contact at a location approximately 60 miles away. The new contact had appeared almost instantaneously, suggesting that the object had traveled between the two locations in a fraction of a second. Such a transit, if accurate, would represent a velocity that exceeded any known aircraft by an order of magnitude. The Princeton vectored a second flight of F-18s to the new location. This flight was being recorded by the forward-looking infrared targeting pod of one of the aircraft. The footage from this targeting pod is the video that has become known as the FLIRN video, the clip that would be released publicly more than a decade later, and that would form the foundation of the modern public conversation about unidentified aerial phenomena. The footage shows a small white shape moving against a darker background, with the targeting system attempting to maintain lock. At one point, the object suddenly moves out of frame to the left at a speed that the targeting system cannot match. The significance of the FLIRN footage lies not only in what it shows, but in the layered sensor data that accompanies it. The object was being tracked simultaneously by radar systems on multiple ships, by the radar of the F-18, and by the infrared targeting pod that produced the visible footage. Each of these sensors operates on different physical principles. Radar detects radio reflections, infrared detects thermal radiation, visible light detects, well, visible light. For an object to register on all of these sensors consistently, it must be a physical object with measurable physical properties, not an optical illusion, a software glitch, or a sensor artifact. The combination of these observations, along with the eyewitness reports from the pilots and the corroborating radar tracks from the Princeton, produced what investigators have called multimodal sensor confirmation. This is one of the highest standards of evidence in incident investigation. When multiple independent sensors using different physical principles all register the same object at the same location, performing the same maneuvers, the probability that the observation is an error or an artifact drops dramatically. Something was there, something physical, with measurable size and velocity, performing maneuvers that exceed the capabilities of any known aircraft. The reaction of the United States Navy to the tic-tac incident is itself revealing. According to multiple participants, the official investigation that followed was minimal. Pilots and radar operators submitted their reports, but no comprehensive review was conducted at the time. The classified status of the radar data prevented public discussion. Personnel were not formally instructed to remain silent, but a culture of stigma surrounding the topic discouraged them from speaking publicly. For more than a decade, the incident remained known only to the small circle of personnel who had been directly involved and to whatever classified channels had received their reports. The incident only became public knowledge in 2017, when the New York Times article on AATIP referenced it and released the FLIR 1 footage. Subsequent reporting by journalists including Leslie Keane, Ross Coulthard, and George Knapp filled in additional details. Multiple Navy personnel who had been involved came forward to confirm the events, providing testimony that was consistent across independent witnesses with no contact with each other in the intervening years. The story that emerged was remarkably coherent. Something had been there in American airspace, performing maneuvers that defied physics, and the institutional response had been to compartmentalize the information and move on. In the years since the tic-tac incident, additional encounters have been documented and disclosed. The USS Roosevelt Strike Group, operating off the eastern coast of the United States between 2014 and 2015, reported regular encounters with unidentified objects during training exercises. The objects displayed similar flight characteristics to those observed by the Nimitz Strike Group, including extreme acceleration, hovering capability, and apparent ability to operate across multiple environments. Some objects were observed transitioning seamlessly from atmospheric flight to apparent submersion in water, a capability that has no analog in known human technology. These transmedium capabilities are perhaps the most physically puzzling aspect of the observed phenomena. Conventional aircraft are designed for one environment. They are optimized for atmospheric flight at particular altitudes and speeds, and their structural and propulsive systems would be destroyed if they attempted to operate in water. Submarines are similarly specialized. Their hulls are designed to withstand pressure, their propulsion is designed for water resistance, and they cannot fly. An object that operates effectively in both atmosphere and water, transitioning between them without apparent structural stress, represents an engineering challenge that lies beyond current human capabilities. It implies materials, propulsion systems, and possibly principles of physics that we do not yet understand. The accumulation of these observations across multiple incidents and multiple sensor platforms has forced military and intelligence analysts to consider the question of what kind of technology could produce such results. The answers fall into a narrow range of possibilities. Either the observations are misinterpretations of mundane phenomena, despite the multimodal sensor confirmation, or they represent secret human technology, despite the absence of any plausible national program capable of producing such capabilities, or they represent technology of non-human origin, despite the obvious implications such a conclusion would carry. The first option is increasingly difficult to maintain in light of the consistency and quality of the data. The second option strains credibility, given that no nation has demonstrated, even in theoretical research, anything approaching the capabilities observed. The third option, however unsettling, becomes increasingly difficult to dismiss as the evidence accumulates. What emerges from the careful analysis of incidents like the tic-tac encounter is a set of specific flight characteristics that recur across multiple cases. These characteristics have been formalized into a framework that intelligence analysts use to evaluate reports of unidentified aerial phenomena. The framework, developed within AATIP and refined by subsequent programs, identifies a small number of observable behaviors that distinguish genuinely anomalous objects from misidentified conventional phenomena. Understanding these characteristics and why they are considered so significant requires a deeper look at what aerospace engineers consider possible and impossible under the laws of physics as we currently understand them. The framework that emerged from AATIP and its successor programs identified 5 specific flight characteristics that, when observed in combination, distinguish genuinely anomalous phenomena from conventional aircraft or atmospheric effects. This framework has become known among intelligence analysts as the 5 observables. Luis Elizondo, the former AATIP director, has discussed these characteristics in public interviews and in his subsequent writings. Together, they define what makes a sighting truly unexplained, separating the cases worth investigating from the much larger number of misidentifications and false alarms that occur in any large dataset of aerial observations. The first observable is anti-gravity lift. This term refers to the apparent ability of certain objects to remain aloft without any visible means of propulsion or aerodynamic surfaces. Conventional aircraft generate lift through one of a limited number of mechanisms. Fixed-wing aircraft use the forward motion of the aircraft to generate pressure differences across their wings. Helicopters use rotating blades to push air downward, generating an opposing upward force. Hover-capable vehicles like the Harrier jump jet use thrust vectoring, directing engine exhaust downward to support the weight of the aircraft. In every case, there is a clear physical mechanism producing the lift, and that mechanism leaves observable signatures, including airflow disturbance, heat exhaust, and noise. The objects documented in the tic-tac and similar encounters appear to violate this principle. They hover stationary in the air without any visible propulsion. They produce no measurable downwash on the surface below. They generate no detectable heat signature consistent with conventional engines. They make no sound, even when observed at relatively close range. The mechanism by which they support their weight is not apparent. If they are operating on conventional principles, those principles are well concealed. If they are operating on different principles, those principles lie beyond current human engineering capabilities. The second observable is sudden and instantaneous acceleration. Conventional aircraft accelerate within limits imposed by their structural integrity, their engine output, and the physiological tolerances of any humans on board. Even the most advanced fighter jets, designed to withstand extreme maneuvers, are limited to accelerations of around 9 times the force of gravity, with brief peaks at slightly higher values. Pilots wearing G-suits can sustain such accelerations for short periods, but anything significantly higher causes blackouts, structural damage, or both. These limits are not arbitrary. They reflect the fundamental relationships between mass, force, and material strength. The objects observed in modern incidents appear to accelerate at rates that would be physically impossible for conventional aircraft to survive. The tic-tac object reportedly accelerated from a hover to thousands of miles per hour in a fraction of a second, which would imply an acceleration of several hundred times the force of gravity. No known material could withstand such forces. No biological occupant could survive them. The implications are stark. Either the objects employ some mechanism that decouples them from inertial effects, or they are unmanned vehicles built to withstand forces far beyond biological tolerance, or they are operating on principles that fundamentally differ from our understanding of inertia and acceleration. The third observable is hypersonic velocity without signature. Conventional aircraft traveling at supersonic speeds produce a characteristic shock wave that creates a sonic boom audible on the ground. They also generate significant heat through air friction, which can be detected by infrared sensors. At hypersonic speeds, generally defined as more than 5 times the speed of sound, these effects become even more pronounced. The aircraft glows with thermal energy, the airframe is subjected to enormous structural stress, and specialized materials are required to prevent the vehicle from disintegrating. The objects observed in modern incidents appear to travel at extraordinary speeds without producing any of these expected signatures. Pilots report no sonic booms. Infrared sensors detect no significant thermal signature. The objects move through the atmosphere as though the air itself is not resisting their passage. This implies one of two possibilities. Either the objects are not actually traveling at the speeds they appear to travel, despite the consistent radar measurements suggesting otherwise, or they are interacting with the atmosphere in a manner that does not produce the conventional resistance and friction effects. The second possibility, if true, suggests some kind of field effect or manipulation of the medium surrounding the object, a capability that lies entirely outside current engineering knowledge. The fourth observable is low observability. Conventional aircraft can be designed to reduce their radar cross-section through stealth technologies, but such designs require specific shapes and materials that come with significant aerodynamic compromises. The B-2 bomber and the F-22 fighter, among the most advanced stealth aircraft in operation, are shaped specifically to deflect radar energy in particular directions and coated with materials that absorb specific frequencies. They are still detectable under certain conditions, particularly by radar systems operating at frequencies they are not optimized to defeat. The objects observed in modern incidents appear to exhibit selective visibility across different sensor types. They are sometimes detected by radar but not visible to the human eye. They are sometimes visible to the eye but produce no radar return. They are sometimes detected by infrared but not by visible light, or vice versa. This inconsistency across sensor types is unusual. A solid physical object should reflect, emit, or absorb energy in predictable ways across the electromagnetic spectrum. The selective visibility suggests either that the objects can actively modulate their interaction with different forms of energy, or that they are not solid objects in the conventional sense, or that something about their nature is fundamentally different from anything in our experience. The fifth observable is transmedium travel. As discussed in the context of the tic-tac incident, this refers to the apparent ability of certain objects to operate effectively in both atmosphere and water, transitioning between the two environments without apparent structural stress. The engineering challenges of transmedium operation are enormous. Atmosphere and water have radically different densities, viscosities, and pressure regimes. An aircraft optimized for flight would be destroyed almost immediately upon entering water at any significant speed. A submarine optimized for underwater operation cannot fly. The objects observed in modern incidents appear to transition seamlessly, suggesting design principles that simply do not exist in current human engineering. Taken individually, each of these five observables might be explained away. A skeptic could argue that hovering aircraft might use some novel propulsion system. Extreme acceleration might be a measurement artifact. The absence of sonic booms might indicate that the objects were not really moving as fast as they appeared. Selective sensor visibility might be a calibration issue. Transmedium operation might be a misinterpretation of separate observations stitched together. Each individual claim, considered alone, has potential conventional explanations. But the framework of the five observables specifies that the relevant cases involve multiple observables occurring simultaneously, documented by multiple sensors with multiple credible witnesses. When all five are observed in the same incident, the probability of a conventional explanation drops to essentially zero. There is no known mechanism that can produce all five effects together. There's no known material that could withstand the implied forces. There is no known propulsion system that operates without observable signatures. The cumulative weight of the observables, when they appear together, forces the analytical question into a narrow range of possibilities, none of which involve conventional human or natural phenomena. The physics implications of these observables have prompted serious theoretical work. Several research papers commissioned during the AATIP program addressed the question of what kind of physics could produce the observed effects. Among the most discussed concepts is the possibility of inertia control or mass reduction, which would address the acceleration problem. If an object could effectively reduce its inertial mass while maintaining its gravitational mass, or vice versa, it could accelerate at arbitrary rates without experiencing destructive forces. The biological occupants, if any, would not be subjected to the crushing accelerations that would normally accompany such maneuvers. Other papers explored the possibility of warp field dynamics, drawing on the theoretical work of physicists like Miguel Alcubierre, who in 1994 published a mathematical framework for how a warp drive might function within the laws of general relativity. Alcubierre's solution describes a region of space in which the space itself is contracted in front of the moving object and expanded behind it, allowing the object to travel faster than light without locally violating relativity. The energy requirements for such a drive, calculated under conventional assumptions, are astronomical. Some hypothetical refinements have suggested ways to reduce the energy requirements, but no demonstrated path exists to producing the required negative energy densities. Yet the warp drive framework provides a theoretical model for how an advanced civilization might achieve interstellar travel without violating known physics. Still, other papers explored exotic propulsion concepts, including electromagnetic field generation, vacuum energy extraction, and metamaterial engineering. The papers were speculative, and they did not claim that any of these concepts had been demonstrated or that they explained the observed phenomena. But they established that the observed flight characteristics, while well beyond current human capabilities, were not necessarily forbidden by physics. They lay at the edge of theoretical possibility, in territory that advanced civilizations might plausibly have explored. This framework of the 5 observables and the theoretical work surrounding it provides a structured way to evaluate the claims being made about unidentified aerial phenomena. The framework has been adopted by various researchers and journalists working on the topic, and it has shaped how official investigations now categorize and assess incidents. The all-domain anomaly. Resolution Office uses a similar set of criteria in its public reporting, focusing on cases that exhibit anomalous flight characteristics rather than cases that can be readily explained. What emerges from the application of this framework is a relatively small but significant set of cases that resist conventional explanation. The tic-tac incident is the most famous example, but it is not alone. Other well-documented cases include the gimbal encounter off the coast of Florida in 2015, the go-fast encounter from the same period, the Roosevelt encounters mentioned earlier, and numerous incidents involving foreign militaries that have been brought to light through international reporting. The Chilean Navy released footage in 2017 of an object exhibiting trans-medium capabilities. The French government has maintained a long-running investigation through its space agency that has documented similar phenomena. The accumulation of cases across multiple countries and multiple decades suggests a global pattern rather than a localized anomaly. The political implications of this accumulating evidence have begun to manifest in formal legislative and oversight activity. The hearings that took place in Congress in 2023 were not the end of this process, but the beginning of a sustained effort to bring institutional clarity to a topic that has been deliberately obscured for generations. Understanding the political dimensions of this effort and what they reveal about the seriousness with which the topic is now being treated at the highest levels of government requires examining the specific testimony and legislation that has emerged in the years since the modern era of disclosure began. The congressional hearings on unidentified anomalous phenomena that began in 2023 marked a turning point in how the American government engaged with the topic publicly. For decades, the question had been confined to classified briefings or dismissed in unclassified settings as a matter of mistaken identification and overactive imagination. The hearings of the modern era took place in formal committee rooms, with witnesses testifying under oath, with full transcripts entering the congressional record, and with cameras broadcasting the proceedings to a global audience. The transformation was not merely procedural. It reflected a deeper shift in how the topic was understood within the American political system. The July 26th hearing of 2023, conducted by the House Oversight Subcommittee on National Security, the Border, and Foreign Affairs, established the template for subsequent proceedings. The hearing was titled with deliberate gravity. The use of the term unidentified anomalous phenomena rather than unidentified flying objects signaled that the legislative branch was now adopting the more measured technical language that intelligence professionals preferred. The hearing's subtitle addressed implications for national security, public safety, and government transparency, framing the topic not as entertainment, but as a matter of governance and accountability. The witnesses at the hearing presented a coherent and disturbing picture. Ryan Graves, the former Navy F-18 pilot, described a culture within naval aviation in which encounters with unidentified objects had become routine, but had been systematically discouraged from being reported through official channels. Graves emphasized that the absence of formal reporting did not reflect an absence of incidents. It reflected an institutional preference for not knowing. Pilots who reported encounters faced subtle but real career consequences. Pilots who remained silent could continue their careers without difficulty. The incentives were aligned toward institutional ignorance, and the result was a body of unreported incidents that almost certainly dwarfed the documented record. David Fravor, the retired Navy commander whose tic-tac encounter has become the most famous case in the modern record, provided his testimony with the precision of a military officer accustomed to formal reporting. He described the incident in detail, including the timeline, the radar tracks, the visual observations, and the physical characteristics of the object he'd encountered. He emphasized that the object had exhibited capabilities that no known aircraft could match, and that the incident had been thoroughly documented through multiple sensor platforms. He also discussed the institutional response in the years after the incident, noting that there had been no comprehensive investigation, no formal interview process for the involved personnel, and no apparent effort to integrate the lessons of the encounter into subsequent training or doctrine. David Grusch provided the most explosive testimony of the hearing. As discussed previously, he made specific claims under oath about the existence of a long-running American program to recover non-human craft and biological materials. He described the program as operating outside normal oversight structures, illegally withholding information from Congress, and engaging in active retaliation against personnel who attempted to come forward. He stated that he had personally interviewed individuals with direct knowledge of the program and had reviewed documentation supporting their accounts. He emphasized that he could not discuss specific classified details in a public setting, but had provided fuller information to the appropriate oversight committees. The reaction of committee members during the hearing was instructive. Representatives from both political parties expressed serious interest in the testimony. Representative Tim Burchett, a Republican from Tennessee, had been a vocal advocate for transparency on the topic and used the hearing to press for additional disclosure. Representative Jared Moskowitz, a Democrat from Florida, expressed similar concerns and aligned himself with the transparency effort. The bipartisan nature of the engagement was striking, given the deeply polarized state of American politics on most other matters. The topic of unidentified anomalous phenomena had become one of the few subjects on which members of opposing parties were willing to work together openly. The bipartisan engagement reflected several factors. First, the topic did not align cleanly with any existing partisan framework. There was no obvious Democratic or Republican position on whether non-human craft existed. Second, the testimony of credible witnesses created political pressure that could not be easily dismissed by either party. Third, the legislative framework that had emerged in previous years had been crafted with bipartisan support, and committee members from both parties had institutional investments in seeing that framework function. Finally, the implications of the testimony, if true, were of such magnitude that conventional political calculations seemed inadequate to address them. In the months following the July 2023 hearing, additional congressional activity continued the process of formalizing the legislative framework for unidentified anomalous phenomena. The most significant development was the introduction of the Unidentified Anomalous Phenomena Disclosure Act, drafted primarily by Senator Chuck Schumer of New York, with bipartisan co-sponsorship from Senator Mike Rounds of South Dakota. The act was modeled explicitly on the Kennedy Assassination Records Collection Act of 1992, which had created a Federal Records Review Board to declassify and release documents related to the assassination of President John F. Kennedy. The Schumer Rounds legislation contained provisions of extraordinary scope. It would have established a presidentially appointed Unidentified Anomalous Phenomena Records Review Board with authority to compel the release of documents related to the topic. It would have created a presumption of disclosure, meaning that documents would be released by default unless specific national security exemptions applied. It would have invoked eminent domain authority over any technologies or biological materials of non-human origin held by private contractors, allowing the federal government to take possession of such materials in the interest of public disclosure and scientific study. The provisions, if fully implemented, would have represented the most aggressive transparency initiative in American history regarding a classified topic. The bill encountered intense opposition during the legislative process. Industry lobbyists, intelligence community representatives, and members of Congress with close ties to defense contractors worked to weaken the most ambitious provisions. The final version, included in the National Defense Authorization Act for fiscal year 2024, retained the general framework, but significantly reduced the powers of the review board. The eminent domain provisions were stripped entirely. The presumption of disclosure was qualified by broader exemptions. The compulsory disclosure requirements were softened into recommendations. The pattern of legislative weakening was itself significant. Reporters who covered the process noted the unusual intensity of the lobbying effort against the original provisions. Industry interests that would normally have little reason to oppose disclosure legislation engaged actively to prevent the bill from passing in its full form. Members of Congress who had supported the original draft expressed frustration at the resistance they encountered. Schumer himself, in floor speeches during the legislative process, suggested that powerful interests were working to prevent transparency on a matter of profound public significance. His statements were unusual in their directness and reflected a level of frustration that is rarely expressed publicly by senior congressional leaders. The intensity of the resistance carried its own implication. If the topic of unidentified anomalous phenomena were truly the empty matter that official statements had long suggested, there would be no reason for such elaborate efforts to prevent disclosure. The energy expended in opposing transparency suggested that something of substance existed to be hidden. The lobbying did not prove the truth of any specific claim about the topic, but it did suggest that those with privileged access to classified information believed there was sufficient sensitivity to warrant aggressive protective measures. The shape of the resistance, even more than its content, served as a form of indirect evidence about the underlying reality. Subsequent hearings continued the process of public engagement. In November of 2024, the House Oversight Committee held another hearing focused on unidentified anomalous phenomena and the implementation of recent legislation. The witnesses included additional military personnel, former intelligence officials, and scientific experts who had been engaged in the analysis of declassified data. The hearing further refined the public understanding of the topic, addressing questions that had been left open from the earlier proceedings and pressing for additional disclosure. One witness at this hearing, Tim Gallaudet, a retired Rear Admiral who had served as a senior official at the National Oceanic and Atmospheric Administration, provided testimony that linked the unidentified phenomena to potential maritime safety concerns. Gallaudet described unidentified submerged objects observed by Navy vessels, suggesting that the phenomena were not limited to the atmosphere, but extended into the world's oceans. He emphasized that such objects, if real, represented potential risks to maritime navigation and warranted serious investigation regardless of their ultimate origin. His testimony expanded the scope of the public conversation beyond aerial phenomena and into the broader category of anomalous objects operating across multiple domains. Another witness, Michael Gold, a former NASA official who had served on the agency's Unidentified Aerial Phenomena Study Group, addressed the scientific dimensions of the inquiry. Gold described the methodological challenges of studying phenomena that were elusive, infrequent, and often documented under conditions that did not permit controlled scientific observation. He emphasized that the standard scientific approach of repeatable experimentation was not directly applicable to a phenomenon that did not appear on demand. New methodologies, drawing on intelligence analysis techniques, statistical inference, and forensic reconstruction, would be required to make progress on the question. His testimony reflected a growing recognition within the scientific community that the topic warranted serious engagement, even if the methods of engagement would need to be adapted. The accumulating record of congressional activity has produced a documentary trail that researchers and historians can now consult. The hearings, the legislation, the executive branch responses, and the legal challenges have all become part of the public record. This documentary trail does not resolve the substantive question of what the phenomena actually are. It does, however, establish that the topic has been formally acknowledged as a matter of governmental concern. The era in which the question could be dismissed as fringe speculation has ended. The era in which it must be addressed as a matter of national policy has begun. What remains contested is the substantive content of the classified information that lies behind the public hearings. The witnesses who have testified publicly have repeatedly noted that they have additional information they cannot discuss in unclassified settings. The committees that have access to classified briefings have suggested through indirect statements that what they have learned in those briefings is significantly more concerning than what has been disclosed publicly. The gap between the public record and the classified record remains substantial, and the slow process of closing that gap is one of the central political projects of the current era. Among the most contested elements of the classified record are the claims regarding recovered materials and the alleged programs to study them. These claims, made most prominently by David Grusch, but supported by additional sources who have spoken to journalists and congressional investigators, represent the boundary at which the inquiry transitions from observational evidence to physical evidence. If recovered materials exist, and if they are of non-human origin, then the implications cannot be confined to atmospheric observation. They become matters of physical possession, scientific analysis, and the question of what has been learned through decades of alleged study. The next stage of the investigation must address these claims directly, examining what has been alleged, what evidence has been offered, and what scientific scrutiny has been applied to the materials in question. The allegations of recovered materials and ongoing retrieval programs represent the most consequential and most contested element of the modern disclosure conversation. If accurate, they would mean that the question of extraterrestrial visitation is not a matter of speculation about distant possibilities, but a matter of physical evidence held in secured facilities. The implications would extend far beyond the academic interest of the Fermi Paradox. They would touch on the fundamental nature of the political reality in which we live, the relationship between citizens and their governments, and the boundaries of what is known and what is concealed. The first public allegations of crash retrieval programs in the modern era can be traced to the work of journalist Leslie Kean and her co-authors. Kean, a longtime investigative journalist who had covered the topic with rigor for years, published a book in 2010 titled UFOs. Generals, pilots, and government officials go on the record. The book compiled testimony from credentialed witnesses, including former military officers, government officials, and pilots from multiple countries who described encounters and incidents that had been suppressed from public discussion. The book was reviewed seriously in mainstream publications and helped establish the legitimacy of the topic in journalistic circles. The allegations regarding crash retrieval programs gained additional substance through the work of journalist George Knapp, who'd been covering the topic since the 1980s. Knapp had developed sources within the intelligence community and the defense industry, and he had been instrumental in bringing the work of physicist Bob Lazar to public attention in 1989. Lazar had claimed to have worked at a facility called S4, located near the Nevada test site, where he allegedly performed reverse engineering analysis on craft of non-human origin. Lazar's claims had been controversial for decades, with critics pointing to discrepancies in his educational and employment records, and supporters noting that he had described specific elements of facility operations that were later corroborated by independent sources. The Lazar case illustrates the persistent challenge of evaluating claims about classified programs. The nature of compartmented intelligence is that those with access to it cannot freely discuss it, while those without access cannot independently verify its existence. Lazar's specific technical claims, including his description of an element with atomic number 115 used as a fuel source for advanced propulsion systems, were dismissed by mainstream science when he first made them. The synthesis of element 115, however, was confirmed by Russian researchers in 2003, more than a decade after Lazar's claims. The synthesized element, named moscovium, is highly unstable and exists only for fractions of a second under controlled laboratory conditions. Lazar's claim that a stable isotope of this element could be used as fuel remains unconfirmed and contradicted by everything currently known about the element's properties, but the broader detail that such an element existed and could be referenced by atomic number proved correct in a way that critics had specifically denied at the time he made the claim. The Grusch testimony of 2023 was significant in part because it brought the allegations of crash retrieval programs into the formal congressional record. Grusch testified that he had been briefed by individuals with direct knowledge of programs that had been operating for decades, that the programs had recovered craft of non-human origin, and that the programs had also recovered biological remains. The specifics of these claims, including the locations of facilities, the names of personnel, and the documentation supporting the existence of the programs, were provided to the relevant congressional committees in classified session. The public testimony was limited to the existence of the claims and to the assertion that they were being made under the legal protections of whistleblower status. The substantive evaluation of these claims requires distinguishing between several categories of evidence. The first category is the testimony of individuals with claimed direct knowledge. Such testimony, while compelling when it comes from credentialed sources, cannot independently establish the truth of the claims being made. A witness can be honest and still be mistaken about what they have observed or been told. A witness can be honest about what they were told and still have been the recipient of misinformation. The chain of inference from testimony to confirmed fact is long and subject to multiple sources of error. The second category is documentary evidence. If recovered craft and biological materials exist, there should be a paper trail. Programs of the kind alleged would involve procurement, security clearances, contracts with private companies, transport arrangements, storage facilities, and scientific analysis. Each of these activities generates documents. Even highly classified programs produce internal records, audit trails, and institutional memory. The absence of such documents in the public record is not surprising, given that the programs are alleged to be classified at extremely high levels. But the existence of such documents, even within classified systems, provides a potential path to verification if congressional investigators with appropriate clearances can locate them. The third category is physical evidence. If recovered materials exist, they should be subject to laboratory analysis. Their elemental composition, isotopic ratios, structural properties, and manufacturing characteristics should be measurable through standard analytical techniques. The results of such analysis would provide objective data that could be evaluated by independent scientists. The challenge, of course, is that the materials in question, if they exist, are alleged to be held in classified facilities with no public access. The chain of custody required to bring such materials into a peer-reviewed scientific framework has not been established, and the political and security barriers to such an arrangement remain formidable. Several public claims regarding physical evidence have been made over the years, with varying degrees of credibility. The most discussed in recent times have involved samples of alleged exotic materials whose isotopic ratios are claimed to differ from anything produced by known natural or industrial processes. Some of these samples have been analyzed by researchers at academic institutions, with results published in peer-reviewed venues. The findings have been mixed. Some samples show unusual isotopic compositions that could potentially indicate exotic origin, while others have been shown to be consistent with industrial byproducts produced through specialized manufacturing processes. The interpretation of the data has been contested, with proponents arguing that even rare industrial processes do not explain the specific characteristics observed, and skeptics arguing that the burden of proof has not been met. The most prominent of these analyses has involved samples held by To the Stars Academy, an organization co-founded by former AATIP director Luis Elizondo and musician Tom DeLonge. The organization acquired samples that were claimed to have unusual properties and arranged for analysis by researchers at multiple institutions. Some of the results, published in technical journals, described samples with isotopic ratios that were not consistent with terrestrial origin under standard assumptions. Critics noted that the samples had been provided by anonymous sources with claims of unusual origin, that the chain of custody was unverified, and that the unusual isotopic ratios could potentially be produced through specialized manufacturing processes. The debate over these specific samples continues, with neither side able to claim definitive resolution. The legal and political framework for addressing claims of recovered materials has evolved significantly in recent years. The provisions of the National Defense Authorization Act for fiscal year 2024, even in their weakened final form, created mechanisms for the formal recognition and disclosure of materials related to unidentified anomalous phenomena. The All-Domain Anomaly Resolution Office has been given authority to investigate claims of recovered materials and to compel cooperation from agencies and contractors who might hold such materials. The whistleblower protection provisions encourage individuals with knowledge of relevant programs to come forward through legally protected channels. The implementation of these provisions has been slow and contested. AARO has produced public reports that have, in some cases, contradicted the claims made by whistleblowers. The office has stated that it has found no evidence to support claims of recovered non-human craft or biological materials. This statement has been received with varying degrees of skepticism by observers familiar with the topic. Critics have pointed out that AARO's authority to access compartmented programs may be limited, that information held under unacknowledged special access. Programs may not be accessible to the office regardless of its formal authority, and that the absence of evidence in the office's investigation cannot be taken as evidence of absence given the structural barriers to access. The tension between official denials and whistleblower allegations creates a difficult epistemic situation for the careful observer. Official statements deserve consideration, but cannot be taken at face value, given the history of denial that preceded the modern acknowledgments. Whistleblower allegations deserve consideration, but cannot be confirmed without access to the classified materials they describe. The result is a situation in which the most consequential factual question, whether physical evidence of non-human origin exists, cannot be definitively answered with the information currently available in the public domain. Reasonable observers can reach different conclusions based on the same publicly available evidence, and each conclusion can be defended with internally consistent reasoning. What can be said with more confidence is that the question is now treated as a serious matter requiring institutional attention. The era in which the question could be summarily dismissed has ended. The committees that have access to classified briefings have repeatedly indicated that what they have learned warrants continued investigation. Legislation is being drafted, programs are being reorganized, and the slow process of institutional engagement is producing a record that future historians will be able to consult. Whether that record will eventually include definitive resolution of the substantive question remains to be seen. The implications of these developments for the Fermi Paradox are significant, regardless of the ultimate truth of any specific claim. If the allegations of recovered materials are accurate, then the silence Fermi described is not silence at all, but a carefully managed information environment. The galaxy may be populated with civilizations that have visited our world, established contact with portions of our governments, and remained hidden from the broader population through coordinated security arrangements. The paradox would dissolve, replaced by a different question about why such contact has been concealed. If the allegations are inaccurate, but the observational evidence of anomalous phenomena is genuine, then the paradox transforms, but does not dissolve. the phenomena would still require explanation. They might represent something other than visiting civilizations. They might be natural phenomena of a kind we have not yet recognized. They might involve aspects of physical reality that our current science is not equipped to describe. The paradox would remain, but its terms would have shifted from why we hear nothing to why we observe things we cannot explain. In either case, the framework for thinking about cosmic isolation must accommodate the possibility that the silence is incomplete. This shift has implications for the various theoretical resolutions of the paradox that have been proposed over the years. The zoo hypothesis, the dark forest theory, and other models of cosmic civilization all assume specific patterns of behavior on the part of advanced species. Examining these models in light of the modern observational record requires reconsidering whether the silence they were designed to explain is the silence we actually observe, or whether the actual pattern of evidence points toward different theoretical conclusions. The zoo hypothesis, in particular, becomes especially relevant when considered against the backdrop of observed phenomena that suggest presence without contact, observation without intervention, and a pattern of behavior that would be consistent with a deliberate policy of restrained engagement.